Do they ruin the environment? With liquids, delight and suspicion go hand in hand. They are duplicitous by nature, neither a gas nor a solid, but something in between, something inscrutable and mysterious. Take mercury, for instance, which has delighted and poisoned humanity for thousands of years. As a child, I used to play with liquid mercury, flicking it around on tabletops, fascinated by its otherworldliness, until I was made aware of its toxicity. But in many ancient cultures, mercury was thought to prolong life, heal fractures, and maintain good health. It's not clear why it was held in such regard, perhaps because it is special in being the only pure metal that is liquid at room temperature. The first emperor of China, Qin Shi Huang, took mercury pills for his health, but died at 39, probably as a result. Even so, he was buried in a tomb full of rivers of flowing mercury. The ancient Greeks used mercury in ointments, and alchemists believed that a combination of mercury and another elemental substance, sulfur, formed the basis of all metals, a perfect balance between mercury and sulfur creating gold. This was the origin of the erroneous belief that different metals could be transmuted into gold if mixed in the right proportions. While that proved to be the stuff of legend, gold does dissolve in mercury. If you heat up that liquid once it has absorbed the metal, it will evaporate, leaving behind a solid lump of gold. For most ancient people, that process was indistinguishable from magic. Mercury isn't the only liquid that can consume another substance and contain it within itself. Add salt to water and it will soon disappear. The salt is somewhere, but where has it gone? Yet if you do the same with oil, the salt just sits there. Why? Liquid mercury may absorb solid gold, but it rejects water. Why is that? Water absorbs gases, including oxygen, and if it didn't, we would live in a very different world. It is the oxygen dissolved in water that allows fish to breathe. And although water can't carry enough oxygen for humans to breathe, other liquids can. There's a type of oil, perfluorocarbon liquid, that is very unreactive chemically and electrically. It is so inert that you can put your cell phone in a beaker of perfluorocarbon liquid and it will continue to operate normally. Perfluorocarbon liquid can also absorb oxygen in such high concentrations that it is breathable by humans. This sort of liquid breathing liquid instead of air, has many possible uses, the most important of which is to treat premature babies suffering from respiratory distress syndrome. Still, it is liquid water that has the ultimate life-giving property. This is because it can dissolve not just oxygen, but many other chemicals too, including carbon-based molecules, and so provides the aqueous environment required for the emergence of life, for new organisms to spontaneously come into existence. Or at least that is the theory. And it is why, when scientists look for life on other planets, they look for liquid water. But liquid water is rare in the universe. It's possible that Europa, one of the moons of Jupiter, might have oceans of liquid water below its icy crust. There might also be liquid water on Enceladus, one of the moons of Saturn. But Earth is the only body in the solar system where a lot of water is readily available on the surface. A peculiar set of circumstances on our planet has made possible the surface temperatures and pressures that can sustain liquid water. In particular, if it weren't for Earth's molten metal liquid core, which creates the magnetic field that protects us from the solar wind, all our water would most likely have disappeared billions of years ago. In short, on our planet, liquid begat liquid, and that led to life. But liquids are destructive too. Foams feel soft because they are easily compressed. If you jump onto a foam mattress, you'll feel it give beneath you. Liquids don't do this. Instead, they flow, with one molecule moving into the space freed up by another molecule. You see this in a river, or when you turn on a tap, or if you use a spoon to stir your coffee. When you jump off a diving board and hit a body of water, the water has to flow away from you. But the flowing takes time, and if your speed of impact is too great, the water won't be able to flow away fast enough, and so it pushes back at you. It's that force that stings your skin as you belly flop into a pool and makes